Assalamu alaikum wa rahmatullahi wa barakatuh. This is Muhammad Zaid, the math teacher of Rabbi International School. Now we're going to talk about solving right triangle. Remember the trigonometric ratios of the right triangle. As you see in the table, for example, if you have a triangle ABC, angle A its opposite small a, and angle B its opposite small b, and angle C its opposite small c. The opposite of angle A again is small a, and its adjacent is small b. Okay, and the hypotenuse is C. So sine A equals opposite over hypotenuse, which is A over C. Cosine A is adjacent over hypotenuse, which is B over C. And tangent A equal opposite over adjacent, which is A over B. If you focus about angle B, its opposite is small b, and its adjacent is small a, and the hypotenuse also is C. Then sine B equals opposite over hypotenuse, which is B over C. Cosine B is adjacent over hypotenuse, which is A over C. And tangent B equals opposite over adjacent, which is B over A. Solving right triangle means find the measure of all angles and all sides of the triangle. For example, if you have the triangle ABC, the three angles is A, angle B, and angle C, and the three sides is CB, AC, and AB. This example demonstrates how can we find the missing sides and the missing angles of the right triangle by the givens side and angle. First of all, you have to find the missing sides and the missing angles. The missing sides are the side xy and the side zy, and the missing angle measuring angle y. So we are going to find small x and small y using the trigonometric ratios. If you want to find, for example, the side zy, which represented by small x is opposite of 71, and the hypotenuse is 32, then we are going to use sine x is opposite over hypotenuse. By substituting, then sine 71 equals small x over 32. By cross multiply, then x equals 32 times 71, which is approximately equals 30.3. If we want to find small y, which is xz here is adjacent of 71, and also we have the hypotenuse. Then we are going to use the cosine x. Cosine x is adjacent over hypotenuse. By substituting, then cosine 71 equals y over 32. Cross multiply, then y equals 32 times cosine 71, which approximately equals 10.4. If you want to find measure angle y, we have to know that angle x and angle y are complementary. Then measure angle x plus measure angle y is 90. By substituting, then 71 plus measure angle y equals 90. Subtract 71 in both sides, then measure angle y equals 19. This example demonstrates also solving right triangle by the givens one side and one angle. For example, the triangle ABC, which has BC length equals 19 and the measured angle C is 52 degrees. First of all, we have to find the missing sides and the missing angle. The missing sides are AB and AC, and the missing angle is measure angle A. Now we're going to find the AB first. AB, according angle C is opposite, and BC 90, which is 19, is adjacent, opposite, and adjacent we are going to use tan. then tan 52 equals opposite, which is AB, over adjacent, which is 19. By cross multiply, AB equals 19 multiplied by tan 52, which approximately equals 24.319. We are going to find now the hypotenuse AC. AC is the hypotenuse and the 19 is the adjacent of angle C. Then we are going to use cosine. Cosine 52 equals 19 over AC, adjacent over hypotenuse. By cross multiply, AC multiply cosine 52 equals 19. Divide cosine 52 in both sides, then AC equals 19 over cosine 52. Then AC approximately equals 30.861. Now we are going to find the missing angle. The missing angle here is angle A. As we mentioned before, angle C and angle A are complementary. Then measure angle A plus measure angle C is 90. By substituting, measure angle A plus 52 equals 90. Subtract 52 from both sides, then measure angle A is 38 degrees. This example shows how can we find the solving right triangle using two sides given. If you have a triangle ABC which has hypotenuse 13 and one of the legs equals 5, so we have to find the missing side and the missing angle first. The missing side is AB and the missing angles are measure angle A and measure angle B. First we have to find the missing side using Pythagorean theorem, which says a power 2 plus b power 2 equals c power 2. As you know, c is the hypotenuse and a and b are the legs of the right triangle. By substituting, 13 squared equals a squared plus 5 squared. Then 169 equals a squared plus 25. Subtract 25 from both sides, then a squared equals 144. By identify square root of two sides, then a equals 12. Then we are going to find the measure angle B. As you know, BC is adjacent of angle B, which is 12, and AC is opposite of angle B, which is 5. Then we are going to use tan. Tan B equals opposite over adjacent. By substituting, tan B equals 5 over 12. The measure angle B equals tan minus 1, 5 over 12, which approximately equals 22.62. To find angle A, as we mentioned before, the both angles A and B are complementary. The measure angle A plus measure angle B equals 90 degrees. By substituting, measure angle A plus 22.62 equals 90. By subtract 22.62 in both sides, the measure angle A equals 67.38. This was last point of today's lesson. Good luck.